Good morning, everyone. Welcome to today's class. Today, lecture number, I think, lecture number 4, right? Okay, in today's class, we are going to deal with questions with two inequalities statements. With two inequality statements, modulus function, modulus inequalities, domain of function, and domain of modulus function. Let's begin. First let us see how multiplication or division works in inequality. Suppose we have two functions f of x, g of x, such that g of x not equal to 0. Then it is given that f of x by g of x is greater than or equal to 0. Okay, how do we proceed with the inequalities? If it was, instead of equation inequality, if it was an equation f of x by g of x equal to 0, then we could have directly cross multiply this, right? Equal to 0, f of x equal to 0. Direct cross multiplication was allowed. But here it is inequality, not equal to. Inequality. To cross multiply, we must know the sign of g of x, whether it is positive or it is negative. Okay, so if g of x is positive, then we can simply cross multiply f of x equal to 0. F of x is greater than or equal to 0. If g of x is negative, we know that it is negative, so f of x will, after cross multiplication, f of x will become less than or equal to 0. Here the sign will be changed, inequality sign changed. That is positive number multiplication, no change in sign, no change in inequality, no change in inequality sign. But if we multiply by a negative, function or a number, then change in inequality sign. If it was greater than or equal to 0, then it will become less than or equal to 0. Or if it was less than or equal to 0, then it becomes greater than or equal to 0. As here in this case, before it was greater than or equal to 0. If when g of x is negative, and if we cross multiply, then it becomes f of x is less than or equal to 0. Okay. And yesterday, I think we have solved up to 2, right? These 5 questions. Among of these 5 questions, we have solved 1 and 2. Today, let's start with number 3. What is the question here? X squared plus 2x minus 3 upon x squared plus x plus 1 greater than 0. So try to factorize both numerator and denominator. Numerator can be factorized as x plus 3 minus 3, right? X plus 3 into x minus 1. 1 into 3 minus 3. 3 plus minus 1 equal to 2x. Okay. And here denominator. Can we factorize this? Not factorizable, right? We cannot factorize it. So if a function is not factorizable, then check its sign. Positive or negative. How do we check? Check A. What is A here? A here is 1, which is greater than 0. And D, discriminant, equal to B square minus 4AC, right? So check it. B means 1 square. Minus 4 into A is 1. C is here 1. So definitely this is D is less than 0. As A is greater than 0, D is less than 0. This function as a whole, x square plus 1, x square plus x plus 1, entire thing is positive, is greater than 0. That is positive. So this is a positive quantity. So we can cross multiply now. As we know the sign now, we can cross multiply. As this is a positive, then x plus 3 whole into x minus 1 is greater than or equal to 0. This is a positive, so no change. No change in sign. Okay, now we can plot as usual. From here minus 3, from here 1. Minus 3 and 1. Right? Minus 3 and 1. plus, minus, plus. As degree are all odd, plus, minus, plus. It is greater than 0 means positive intervals. So positive interval means hollow circle because this is strictly greater than 0. This one and this one. So x belongs to minus infinity to 3 open bracket union open bracket 1 to infinity. This is the solution. Okay. This one, remember this, not factorizable. Then check the sign of the given function. If it is positive or negative. If we know the sign, when we know the sign, we can cross multiply or multiply. If it is positive, no change in inequality signs, no change. If it is negative, change the symbol. Greater than to less than, or less than to greater than. Okay, this is important. Next question. One by x minus 1 less than or equal to 2. Here this is 2. I told you to make it to 0, right? It should be 0 always on the right. So make it 0. We must make it equal to 0. So we can transfer to this side. X minus 2 less than or equal to 0. When you LCM x minus 1, 1 minus 2x plus 2, right? Here minus 2 already there. Here minus 1. So plus 2 less than or equal to 0. Here this 2 becomes 3. 3 minus 2x. In the denominator we have x minus 1. This one is not, this is a linear function. We don't know the sign. We don't know its sign. So we cannot cross multiply. We cannot cross multiply as we don't know the sign of this. So we will leave it as it is. See in the numerator. Here in the numerator x, I told you to keep x as always positive. So here it is negative. So we will try to remove this x, this minus, this negative value. So we can take negative common. Then 2x minus 3. 2x minus 3 divided by x minus 1 is less than or equal to 0. Now we can we can multiply both sides by minus 1. So when we multiply by a negative value, the inequality symbol changes, right? So 2x minus 3 divided by x minus 1 greater than or equal to 0. Now we can plot. From here we will get 3 by 2. From here we will get 1. Critical points are 3 by 2 and 1. 1 here and here 3 by 2. Since 1 is smaller, it is on the left. This is bigger, so on the right. Both are linear and degree are 1. So odd, plus, minus, plus. Rightmost is plus, minus, plus. Since it is greater than 0, it will take the positive intervals. Here is a positive interval, here is positive interval. So it will take this value, these intervals. And here dark circles here. Because equal to is there, right? Equal to is there, so dark circle. Here also. Here it will be dark circle or hollow circle. Not here. This is important. Check this point. Check. When x equal to 1, denominator equal to 0. If denominator is 0, the function, the entire thing is undefined. Undefined. So 1 must be excluded. 1 must be excluded. Therefore, this will be a hollow circle, not a dark circle. It will be a hollow circle. Hence, the final answer is x belongs to minus infinity to 1 union 3 by 2 closed. 3 by 2 comma infinity. This is the final solution. Got it? Here why hollow? Because denominator becomes 0 if we put x equal to 1. That is why we are keeping it as we are excluding this point, this critical point. We are excluding this root or critical point. Why including this 3 by 2? If we put 3 by 2, numerator becomes 0. Numerator becomes 0. 0 by something is 0 by something greater than or equal to 0. This means 0 greater than or equal to 0, which is true. Right? 0 greater than or equal to 0, it is true because 0 is equal to 0. If it was only 0 greater than 0, then false. And in this case, if it was 0 always only greater than, strictly greater than 0, we will exclude 3 by 2 as well. But here it is greater than or equal to 0. Greater than or equal to 0. So one statement of greater than or equal to one of them is true. This is true. So we are including 3 by 2. Got it? Next. Question number 5. This is very easy. 1 by x greater than 2. So we will make it to 0. We will have to make the right side equal to 0. So transfer 2 to the left side, minus 2 greater than 0. This implies 1 minus 2x divided by x greater than 0. Here also again negative. X is negative here. X is negative here. X must be positive. So x common, 2x minus 1 divided by x greater than or equal to 0. Right? So multiply by minus both sides. 2x minus 1 by x. Now this symbol will change, less than 0, since I multiply with negative sign. Okay. Now plot the points. Plot the critical points. From the numerator we get 1 by 2, and from the denominator 0. 0 and 1 by 2. 0 and half. So both are degree 1. So plus minus plus. It is less than, right? Now we will not consider this one. Given inequality is greater than, but here what we have got, it's less than. So we will check where the negative intervals are. Negative intervals not equal to is there, so it will be negative interval is this portion. So we will hollow circle, 1 to half, 1 to 1 by 2. X belongs to hollow open 0 to half. This is our solution. Got it? Next, let us do two inequality statement. Here one statement, another statement, and here n x square plus 2x minus 3 greater than or equal to 0, and x square minus 4 less than or equal to 0. Two inequalities are given. So here I will get solution, one solution here another solution, right? Let's name it as solution 1, and this is as solution 2. And then here between them question is given a and d, n, right? So n means we have to do intersection. Okay, and so trick to remember is to use intersection. Then we have to do intersection is a. Take a symbol is like this, right? So a we can write like this, right? Removing the bar. This bar we can remove. This bar, if we remove, it looks like intersection symbol, right? Intersection symbol. So when n is there, a and d is there, then use intersection symbol. Intersection of, that is, the final solution will be solution 1 intersection solution 2. Find out the individual solution and do intersection of both the solution. Got it? So let's solve it. A looks like intersection symbol. Remember, okay. First question is x square plus 2x minus 3. We can factorize it as x plus 3, x minus 1 greater than or equal to 0. From here we will get minus 3 and 1. So greater than 0 and plus minus plus. Greater than 0 means and equal to is there, so dark circle. This side and this side. This is the solution from this. Okay. This is solution 1. And for this one, x square minus 4 we can be written as x minus 2 all into x plus 2 less than or equal to 0. Then from here two critical points are there, 2 and minus 2. Minus 2 is smaller, so on the left, 2 is there on the right. Okay, plus rightmost is plus minus plus, plus minus plus. Okay, and it is less than 0 means negative interval. Equal to is there, so dark circle here. Minus 2 to 2 is there. Now combine intersection. Let's take a number line. Plot this first. Minus 3 1. From minus 3, from solution 1 I got this 1, also I got this up to infinity, right? And then I will change the color for solution 2. From solution 2, minus 2 and 2, right? Minus 2 means somewhere here, minus 3 and minus 2, and 2 means somewhere here. Dark circle here, dark circle. According to solution 2, this is yellow line, yellow graph is the solution 1, and pink graph is the solution 2. So let us see where their intersection is, common point. We have to check the common point. Intersection means common point, right? Here I'm getting the common point. So final solution would be this common area. This is the final solution. This is 1 to 2. Therefore x belongs to close interval 1 to 2 close interval. This is the final solution. From here we get this as the solution 1. Solution 1, and this as solution 2, and then common point. Let's say common interval. Common interval is the final solution. Okay, let's do one more question. Here, from here, it can be 27, right? 3 9s are 27. So we can factorize as x plus 9 whole into x minus 3 greater than or equal to 0. And this one, x minus 3, x plus 3, right, less than 0. N is there, so symbol, intersection. N is there, so intersection is there. This one, from here we get 2.3 and, sorry, minus 9 should be here, and 3 is here. Hollow, it should be greater, plus, minus, plus. So hollow means this is solution 1, and from here minus 3 and 3 less than 0, right, plus, minus, plus. This is solution 2. Solution 1, this is solution 2. So combine both. Minus 9, minus 3 and 3. Minus 9, 3 is here, 3 is here. According to solution 1, let me plot different color. For solution 1, let me use green. For solution 1, let me use green. And for solution 2, let me use yellow. 2 means minus 3 to 3, right? And this is also open. This is also open, right? Open. So what is the solution here? What is the common point here? There's no common point. If this was dark circle, both are dark circle, then we could have said that 3 is the common point. But here it is open, here this is also open. So x belongs to 5. Or we can write as x is empty set. This is the final solution. Got it? This is the no common point. No common interval or point. Got it? Next. Here, from the first inequality statement, we get x plus 3. Here, 3, 3, right? So x plus 3, x minus 1, greater than or equal to 0. Here we will get minus 3 and 1. Minus 3, 1. All are degree 1, degree odd, plus, minus, plus. So for first solution, it is greater than or equal to 0. Greater than or equal to 0 means positive interval. Dark circle, this. And again, dark circle, this. This is the solution 1. N is there, so intersection. Here, x minus 1, x plus 1. Minus 1 and 1, plus, minus, plus. This is less than or equal to 0. So it will be dark circle 1 to dark circle minus 1 to dark circle 1. This is our solution from here. Combination, if we combine minus 3, minus 1 and 1. From minus 3, this, and 1, this, 1 to infinity. And from second solution, minus 1 to 1, right? So minus 1 is dark circle here. To again dark circle 1. So what is the common point here? Only 1 is the common point. Here also dark circle. From first solution we get dark circle here. That means 1 is included. And from second solution, dark circle on 1. So 1 is this is only common. Therefore, x equal to 1. That is, x belongs to singleton set 1. Got it? This is the answer. Next, domain of a function. Domain of a function. What is domain? Domain of a function is nothing but values of x. What happened? Stuck again. The domain of a function is value of x. Value of x for which the function is defined. For which the function is defined. Example, let's see. If there is a function 1 by x, 1 by x is a function. Let us see. X, if we put x as 1, it is defined. 1 by x equal to 1. If we put 2, it is defined. If we put 3, it is defined. So 1, 2, 3, etc. are values of x. So domain means, we can take as 1, 2, 3 here. Suppose if I put 0, 1 by 0, is it defined? Undefined. Undefined. So 0 cannot be the value of x for this function 1 by x. So x can be any r, any real value except 0. Right? This is domain. Got it? Value of x for which the function is defined. Here, if I take 1 by x as an example, as a function, then 0 cannot be the value of x. Any other real values can be taken as the value of x, because x is defined over r except 0. When we keep x as 0, the function becomes undefined. The function is undefined. So values of x for which the function is defined is called as domain of the function. Example, 1 by x is this. F of x is defined for all x belongs to r except 0. Therefore, domain x belongs to R equal to, or x, in the first class I told you that R naught represents this one, real value, all real value minus 0, singleton set 0 is R naught, represented by R naught, or we can represent like this. Why it is stuck? Now you know what domain is, right? So let me explain you this. System is stuck. Okay, see, question may be of any of these three form. Okay, let me explain that. Our given question can be of the form type, for example, f of x. If the given function is f of can be 1 by f of x. Number one type question can be of this 1 by x. As I told you, 1 by x, x can be any real value except 0, right? So in this case, the remark will be, what you have to do is f of x, 1 by f of x is the function, then f of x cannot be 0. This is how you have to identify. 1 by x means f of x should not be 0. From here, you have to start solving the given question. Example, it is given as 1 by x square plus x plus 1 greater than equal to 0. Find the domain. Find domain. Then first equate this 1 plus x plus 1. This is the function, right? So it should not be equal to 0. From here you have to solve. X, remove all the x where it becomes 0. That is your solution. Number 2. Number 2, it could be given x, f of x root over x. I told you in the first class that, in second or first class, that root over x is defined only when x is greater than or equal to 0, right? So here f of x should be greater than or equal to 0. You have to use this and then solve the question. And number 3, 1 upon root over f of x. This is similar to this, right? Only difference is here it is root over f of x. Root over the function is in the numerator. Here it is in the denominator. In the denominator, we said that denominator cannot be 0, right? So combine these two. Combine these two. Then f of x here, it cannot be equal to 0 and it should be greater than 0. So it will be strictly greater than 0. Right? These three, remember this three. This three is very important. You can either note down from the previous slide here. So let's start solving some question. Here in the first one, x belongs to R except 0. Okay. Next, let us try to let us try to solve this. What format is this? This is 1 by f of x, right? So what I just told you that f of x cannot be equal to 0. This is in the denominators, right? So f of x cannot be equal to 0. So we will use this. Using this, we will solve the question. That is 1 by this. That is x square plus 2x minus 3 should not be equal to 0. Right? This implies you can factorize this. X plus 3 into x minus 1 does not equal to 0. This implies from here it is minus 3. From here it is 1. So x cannot be minus 3 or 1. Right? This means x can be, this is our real value, x-axis. X-axis means real number, right? Means minus 3 and 1. Here it will be hello. Except minus 3 and 1. Everything on x-axis is the domain of the given function. Therefore, domain x cannot be minus 3 or 1. So domain of the function x belongs to R. Real number is all real number minus these two. Singleton set minus set 3 comma 1. These two are excluded from R. This is the solution. Or it can be written as R means minus infinity to infinity. This is complete R, right? Minus 3 and 1. Discrete format of set including minus 3 and 1 as its element. Okay. Next. what format is this? It is root of f of x. Root of f over x. This implies f of x should be greater than or equal to 0 because root over x is defined for non-negative, right? There is non-negative means x is greater than 0 or equal to 0. Non-negative means it should be the positive or equal to 0, right? So that is x square plus 2x minus 3. This, the value, the thing inside the root should be greater than or equal to 0. Root over x is defined only when x is greater than or equal to 0, right? So this thing, root over, and thing inside the root over, inside the root should be greater than or equal to 0. From here you can solve x plus 3, x minus 1, greater than or equal to 0, right? So float it on the minus 3 and 1, plus minus plus. This is greater than or equal to 0. So it will be plus interval. It will be plus interval. Therefore, x belongs to minus infinity to minus 3. Minus 3 here it will be including minus 3. So it will be third bracket here, close bracket, union, close here again, 1 to infinity, 1 comma infinity. This is the final solution. Next, y equal to root over x by 2 upon x minus 1 minus 2. So what format is this? This is nothing but root over f of x, right? This is, from here we will get f of x is greater than or equal to 0. So let's solve this. Solution here, x minus 2 by x minus 1 minus 2 greater than or equal to 0. This whole thing inside the root should be greater than or equal to 0. LCM, if you take LCM, x minus 1 in numerator, x minus 2 minus 2x minus into 1 means plus 2, right? 2 will get cancelled, 2x and x and minus 2x means minus x greater than or equal to 0. This implies minus x divided by x minus 1 greater than or equal to 0. Minus, right? Eliminate this, multiply with minus, then x by x minus 1 less than or equal to 0. This sign will be changed because we are multiplying by minus to get this. Now you can plot. From numerator we get 0, from denominator we get 1. Critical points, so plus minus plus. So since this is less than 0, that means negative intervals, and equal to is there, right? So we will use dark circle including 0 and 1. Should we include 1 or not? We will not include 1 here. If we include 1, denominator becomes 0 and undefined. Got it? So we will not use 1. Therefore x belongs to close interval 0 to open interval 1. That means 1 is not included. Write down this note. This is this basic note. Basic 3 types of questions mostly. 1 by f of x. If you get f of x 1 upon f of x format, then always equate f of x does not equal to 0 and solve. Number 2, if it is root over f of x, root over is defined only for non-negative, so f of x must be greater than or equal to 0. You must use this to solve. Number 3, 1 upon root over f of x. Root of f of x, root over f of x must be greater than or equal to 0. But here again, it is again on the denominator, so it will not be equal to 0. So f of x will be greater than 0. That means positive only. Got it? This is important. Remember this. Next, the given question is y equal to root over x square plus 2x, x square plus 2x plus minus 3. Find the domain. So given equation, this is of the form 1 by root over f of x, root over f of x. So f of x should be greater than 0. That is, f of x should be greater than 0. This implies x square plus 2x minus 3 should be strictly greater than 0. So we can factorize this, x plus 3, x minus 1 greater than 0, minus 3 and 1, plus minus plus. So it is greater than 0, so no equal to sign is there, so it will be hollow circle this. Therefore x belongs to minus infinity to minus 3 and open 1 to infinity. This is the solution. Next, inequality of the form. Example, x plus a into x plus b. That means two linear factor, two linear factor. That means two brackets, How many brackets are there? One is there, and second, two brackets or two linear factors. Inequalities of the form inequalities that can be broken down into two linear factors. Two linear factors. Two linear factors. Linear means degree 1. Two linear factors. For this type of equation, example x plus. Okay, let's take an example to understand this. Example 1, x plus 5, x minus 3, greater than or equal to 0. Right? From here, it is minus 5. From here, 3. You can plot it as minus 5 and 3. Right? Plus, minus, plus. Greater than or equal to 0, it will be this one. Dark circle here. This is the solution. Beyond, less than, what does this mean? This means x is less than or equal to minus 5. Right? And what does this mean? X is greater than or equal to 3. Right side means greater always. Left side is smaller one. This means x belongs all this area up to minus 5, and again x belongs from 3 to all this up to right side. This means, what does this mean? This means x is less than minus 5. F is all value towards the left of minus 5. All value towards the left of minus 5. X can take all values to the left of minus 5, including minus 5 itself. And here in this case, 3, including 3, x takes all the value to the right of 3, including 3. That means x is greater than or equal to 3, and here x is less than or equal to minus 5. Right? Conclusion. Instead of using this Webby curve method, we get, if there are two linear factors or two brackets, then we can directly jump into a conclusion. Then if here say it is greater than, if it is greater than, this means this we can form an arrow, right? If arrow is away from the function, here suppose f of x greater than 0, right? This means if we put a straight line here, we get an arrow. If arrow is away from the function, right? If it is away from the function, means solution will be away from the critical points. Away from the critical points. Two critical points will be there. It will be away from the critical points here, and x will be lesser than or equal to the smaller critical point, and x will be greater than or equal to the larger critical point. Here in this case, minus 5 is smaller, right? So minus 5 is less, x is less than or equal to minus 5, and 3 is bigger one, so x is greater than or equal to the larger critical point, that is 3. Here it is minus 5. If arrow is away from the function, this is function, and arrow is away, then the solution will be away from the critical point. Critical point 1, critical point 2, critical point 1, critical point 2. It will be away this side and this side. If critical point 1 is smaller, then x will be smaller. X will be less than or equal to critical point 1, and CP2, critical point 2 is bigger one, then x will be greater than or equal to critical point 2. Got it? Let us do this with another example here. Suppose example number 2. Let's take this example. X plus 5, x minus 7 is greater than or equal to 0. Here, what is the arrow here? Arrow is this side, right? If you put arrow, this is the function. It's away from the, arrow is going away from the function, right? So its value will be away from the critical point. Here critical point is minus 5, and from here it is 7. Which is bigger? 7 is bigger, 5 is smaller. So x will be less than or equal to minus 5, and x will be greater than or equal to 7. Got it? In between, no solution. Only away from this. Right side of the bigger one and left side of the smaller critical point will be the solution. Got it? Here x is less than or equal to minus 5, and x is greater than or equal to 7. That means x can be written as less than or equal to minus 5 means minus infinity to 5, including 5, and union here greater than 7 means including 7 up to infinity, and 5 to 7 in between, no solution. Right? Got it? And what if the arrow is toward the function? Suppose this is function, and if it is less than or equal to 0, if we put here a straight line, it becomes an arrow, right? Arrow is coming towards the function. See here, arrow is coming towards the function. That means converging, right? So it will have two critical point 1, critical point 2. This, what I'm explaining now, this method works only when we have quadratic functions or two linear factors. That means only two brackets will be there. Only then this direct method can be used. Otherwise, you use Webby curve method. If you do Webby curve method, you will have to plot this critical point and then find out plus minus plus, right? But if this is a linear factors or two bracket only two bracket, then you can use directly this arrow method. Arrow away or arrow towards. This is function and this is function. This is away, right? Arrow is going away and this arrow is coming towards. If arrow is coming towards, the solution lies between these two, between the two critical points. Suppose critical point 1 C1 is smaller one and critical point C2 is bigger one, then X lies between these two only. Okay, let me summarize and then we will do example for function reducible to two linear factors or quadratic function. Quadratic function means we can reduce into two linear factors, right? Quadratic function that is of the type x plus a or x plus b, like this. Two bracket, one bracket and two bracket, two linear factor 1, linear factor 2 greater than or this. Then we can use then direct method. Number 1, arrow away from function. That is f of x is here and means greater than or equal to 0. This means arrow is away, right? This is, we can imagine as, right, this is arrow away. Then if arrow is away means you are going away from the critical point. Critical point 1, critical point 2 means this is going away from the critical point 1 and this is going away from the critical point 2, where C2 is greater than C1. If C2 is greater than C1, then the value of x will be going away from C2 towards the right, and smaller one is C1, so towards the left. Okay, so x lies within critical points. That is critical point, this is beyond. Going away means beyond. X is beyond critical point 1 and critical point 2. This is critical point 1, then it will be this one. Critical point 2, then x will be this one. There is no x in between. X is this one, the value of x, that is x is less than or equal to C1. Towards the left means in a number line, any number on the left, suppose this is a, any number on the left of a is smaller than a. That is why you see directly we can say x is less than or equal to C1. And towards the right, any numbers towards the right of a, these are greater than a. That is here x is greater than or equal to C2. Got it? This is point number 1, when arrow is away from the function. Let's do for point number 2. Let me explain point number 2. Point number 2, arrow towards function. That is f of x is less than or equal to 0. This looks like f of x is, arrow is coming towards f of x means f of x, right? This looks like, if I put arrow here, arrow is coming towards the f of x. In this case, x lies within critical point C1, C2. That means x will be somewhere in between this, somewhere between C1 and C2. C1 less than or equal to x less than or equal to C2, or C1 less than x less than C2, based on the inequality given. If it is this, then this one. If it is this, then this one. F strictly lies. If this is only less than, if it is less than or equal to, then less than or equal to C1 less than or equal to x less than or equal to C2. Okay. Summary. You can note down this summary. Arrow is going away. Arrow is coming. If arrow is coming, then x will be here, and then C2, C1, C2 here. Two critical points. Okay, this will be or C2 less than x or less than C1 less than or C2, or C1 less than x less than C2. This is for greater than less than or equal to 0, and this is less than strictly 0. Got it? And for this one, if x will be lesser than or equal to C1, or x will be greater than or equal to C2. That is, C1 is here, x will be this side, and C2 is here, x will be on the right of C2. X, in between no x, no value of x. Got it? This is important. We are going to do 2 examples now. You can note down later on, right? Example: f of x plus 5 into f of x plus 5 whole into x minus 3 less greater than or equal to 0. And number 2 example, same example, let's take x plus 5 whole into x minus 3. Let's take the same example, x minus 3 is less than or equal to 0. Here, critical point is minus 5, critical point is 3, and f of x, it is going away from the function. Arrow is going away from the function. See, arrow is going away. Away means value will be away, right? Value will be away. Means 5 is here, then minus 5 is here, then it will be away towards the left, and 3 here away from the 3. And equal to is there, so 5 will be included. And equal to is there, so 3 will be included. That means x is less than or equal to minus 5. Or x is greater than or equal to 3. Therefore, x will be infinity to minus 5, minus infinity to minus 5. This will be included because 0 equal to is there. Union 3 to infinity. 3 to infinity. Got it? This is the solution. Here in this case, minus 5 and 3. Here, arrow is coming towards the function. Arrow is towards the function. So, x will be between these two. Minus 5 less than or equal to x less than or equal to 3. Directly we can conclude. When we see only 2 brackets. If there are 3, any other factor, x plus 5, x minus 3, x minus 7, there are 3 brackets, so we cannot use this direct method. In that case, we will use wavy curve method, that plotting point. Wavy curve method. We cannot do the shortcut. If for 2 brackets or 2 linear factors, then we can use directly arrow away or arrow coming. Arrow towards or arrow is going away. Okay, next, let's do some examples. To understand the direct method, we are doing this here. We have to check whether this is reducible to 2 brackets or not. X minus 3 into x plus 2, right? 2 into 3, 6, yes, plus 2 less than 0. Here, from here 3, from here minus 2. Minus 2 always on the left, okay? Smaller one on the left. Here it is, arrow is towards the function. So, towards the function means x will be in between these 2 critical points. Here, x will be here, in between this. That is, x belongs to minus 2 to 3. Here, if equal to is there, then we will use close bracket. Got it? Similarly, x minus 3 minus 6 less than or equal to 0, then here we know that minus 2 and 3, right? So, x will be in between, since arrow is coming towards me, towards the function. So, it will be equal to will be there because equal to is there. Here, equal to is not there, so it is strictly this. Therefore, x belongs to minus 2 to 3 here. Difference. Here it is open, okay? Open bracket, and here it is closed. Now here check this one. Can we break this into, yes, x minus 3 into x plus 2. What? See, the arrow is away. Arrow is away from the function. This is the function and arrow is away. Function is this and arrow is away. So, minus 3 and 2. Away means x will be towards the right and towards the left of minus 3. That means x is less than or equal to 3 minus 3, or x is greater than or equal to 2. Therefore, x belongs to, this will be or means union, right? Or means union. X will be belongs to minus infinity to minus 2. This is 2, right? This is 2 and this is 3. Sorry, my mistake. Here it is 3 and here it is minus 2. So minus 2 here and 3 here. it will be minus 2. X is less than minus 2 and x is greater than minus 3. X is greater than 3. 2 minus 2 including minus 2 union, and then 3 to infinity. This is the solution. If arrow is away, then means x will be beyond. Away means beyond. Beyond means bahar, outside, beyond or outside critical point. And here arrow is towards function. Function के पास arrow आ रहा है, तो the x will be between the critical point 1 and critical point 2. Critical point 1 and critical point 2. Whichever is smaller on the left and whichever is larger on the right. Here same thing. If arrow is away or beyond means x should be outside the critical points. Whichever critical point is larger, x will be towards the right of that and x will be towards the left of the smaller critical point. Next, one example here. Here, see. This can be factorized into sine theta plus 1 by 3. This means 1 by 3 whole square, right? A square minus b square formula. Sine theta minus 1 by 3 is greater than or equal to 0. This means arrow is away. That means x will be outside the critical point. Minus 1 by 3. From here it is 3. So x will be this side and this side. X is less than, this is equal to is there, right? So minus 3. X is less than or equal to minus 1 by 3, and x is greater than or equal to 1 by 3. Therefore, x will be, that means here, not x, here it is sine theta. Solution for sine theta. Sine theta, okay. That is, sine theta belongs to, one more step, let me write. Sine theta is less than or equal to 1 by 3 union. Sine theta greater than or equal to 1 by 3. This can be written as x belongs in, mistake always. Sine theta belongs to here less than 1 by 3 means minus infinity to 1 by 3, right? So minus infinity to 1 minus 1 by 3, including 1 by 3 union, here 1 by 3 to infinity. This is the solution. Got it? Next, modulus function. Inequality. We have done so many questions on inequality. Now let's proceed to next point, modulus function. Modulus function, point number 1, write down. If f of x is a function is equal to mod of x, modulus of x. What is modulus function? Modulus function is nothing but a function f of x is equal to mod of x. This is called modulus function. This is called modulus function. If f of x equal to mod of x, then the function f of x is called a modulus function. Then f is a modulus function. Point number 2. F of x, in the earlier classes, I told you that mod of x is equal to this, right? Or vice versa. If x square is given, then I can write as mod of x, or x minus 1 whole square root over x minus 1 whole square is nothing but mod of x minus 1. So if any mod is given, x plus 1000, mod of x plus 1000, then we can write as root over x plus 1000 whole square. This root over. Got it? Or example, sine theta is given within mod, then we can express it as root over sine square theta. This vice versa. You should know this. This is important. Okay. Point number 3. Root over minus root over minus 10. What is it equal to? This is minus of minus 10 equal to 10. Not directly 10. We are getting the positive value 10 because of this formula. I told you in first class that mod of x is nothing but is equal to x if x is greater than or equal to 0, right? And minus of x if it is greater than, if x is less than 0. Example here. Here minus 10 is given inside. Okay, so this will be of this format, right? X. Here x is minus 10. This minus 10 itself is x. Not only 10. 10 is not the x here. X is minus 10. So formula, according to formula, minus is there. X, right? Here x means what? Minus 10. So minus of minus 10 is equal to 10. That is how we get positive 10 for any value of minus x. Suppose minus 100. We are getting plus 100 because of this. Minus of minus 100 equal to 100. Got it? Wait a second. Let me create some space. Let's write down this. Suppose f of x is equal to, in function format we can write like this, f of x and minus f of x when f of x is greater than or equal to 0, and it is equal to minus of fx when f of x is less than 0, right? F of x mod of f of x is equal to f of x itself when f of x is greater than or equal to 0, and mod of f of x is equal to minus of f of x minus of the function if the function itself is less than 0. Got it? Example, mod of plus 2 is equal to 2 only, the number itself here, right? And again, if mod of minus 2 is a negative, right? Minus 2 is less than 0, so it will be equal to minus of minus 2 equal to 2. Got it? This is how mod function works. Next, modulus function, point number 4. Write down point number 4, continuation. Modulus function, continuation. In point number 4, write this down. Mod of x is always non-negative. Mod of x is always non-negative. That is, the final output of mod of x should be greater than or equal to 0. If x is 0, it will be 0. Otherwise, whether x is minus or plus, it will be always greater than 0. It will always give a positive value except for 0. Example, minus of root 3 is less than or equal. If it is given minus root 3 is less than mod x less than root 3, it is given, then how do we conclude? See, this is a given. While solving any question, or it is given to us like this, minus of root 3 is less than mod x less than root 3. Then how will we proceed further? Okay, here just see here, this is a negative value. And mod x, final output, what I said, it will be always greater than 0, or it will be 0 only when x is equal to 0, right? So here it is, let us assume positive or 0. When x is equal to 0, it will be 0, no negative. So negative number on a number line, 0 is here. Negative numbers are towards the left of 0, right? So 0 or positive numbers are always greater than negative number. This is always true, right? This statement is always true. Got it? Here minus 3, minus of root over 3. This is negative already. Clearly this is negative. That means lying somewhere towards the left of 0, right? So mod of x, I told you that it is non-negative. So towards the right of here, it will be mod x. What number we don't know, but this will be always greater than or equal to 0. Mod x is always greater than or equal to 0, and all negative will be towards its left. So mod x will always be greater than negative value. This is always true. If statement is given, if the statement is always true, then we can ignore that part of this statement. Suppose here the statement is given statement. In a given statement, if one statement is always true, we can ignore that part, that one statement, and consider the rest. Here see, minus root over 3 is less than mod x less than root 3. Here minus negative value, right? Minus root 3 is, and mod x is positive or 0, non-negative. Non-negative is greater than negative. So this is always true, universal truth. So we can ignore this. So directly we can conclude as mod of x is less than root 3. This is how we should solve a given question. You will be solving a question, and finally a step will come where it ends like this. In such a statement, then you have to conclude like this. Got it? You can write this down. Not not in a given statement with two or more substatement. The substatement which is or are always true, just ignore them and use the remaining statement to solve the question. Okay, here see, minus root 3 is less than mod x less than root over 3. Here this is always true, this is always non-negative, greater than or equal to 0, and this is negative. Negative is less than non-statement, always true, universal truth. So this part of the statement can be ignored. So the remaining part, mod x less than root 3, we will proceed with this, mod x less than root 3. Okay, then from here we will continue solving the question. Got it? Okay. Modulus inequality, modulus function, then now inequality. Inequality involving mod. Inequality involving mod is called modulus inequality. Example here, mod x less than or equal to 2. Find x. Question can be find x. Here this is an inequality involving mod, so we call it as modulus inequality. Now let's try to solve this. Here what I told you in the first class, I told you that x square is nothing but mod of x, or vice versa. If mod of x is given, then we can write as root over x square. This root over x square is mod of x, so we can write mod x equal to root over x square. Here mod of x, write it as mod over x square. Root over x square less than equal to 2, right? System, what is the issue? Okay, so if you square, it will be 4. This will become x, and this will become x less than 4. X square less than or equal to 4. This implies x square minus this. You can transfer 4 to this side, right? This is nothing but x minus 2 all into x plus 2 less than or equal to 0. Two factors. Now we got that two linear factor, two linear LF, two linear factor, or two brackets. So arrow is towards, right? Arrow is towards the function. So it will be here critical point is 2, here critical point is minus 2. Though x will lie between minus 2, x and 2. This is how we solve. That is, x belongs to open interval minus infinity to minus 2 closed union 2 to infinity. This is the solution. Nothing, that is x is minus 2 to 2. Oh, sorry. This is minus 2 is less than or equal to x, right? And x is less than or equal to 2. That means on the number line minus 2 to 2 from here to here, right? Therefore, x belongs to minus 2 to 2. This is the solution. Here arrow coming. Arrow is towards the function. Function is here. Arrow is coming towards. So solution lies between. X will be this. Solution format will be this. Critical point minus 2 and 2. Equal to sign is there. So I'm using this equal to. This is nothing but x belongs to minus 2 to 2. Close interval. Got it. So let us do some more examples. Then you will know this easily. Okay. I think I had how to solve, not this down point, important point. Now how to solve functions, how to solve quadratic inequality function or two linear factors inequality or two brackets. Okay, first method is the usual method is Webby curve method for all inequalities. You can use this. And number two, if it is two linear factors, then another direct method, two arrow methods. Arrow going away or arrow coming towards the function. Arrow methods. That means f of x is arrow is going away and f of x arrow is coming towards. If arrow is going away, then x will be beyond. X will be less than or equal to the one critical point, the smaller one, smaller critical point, and x will be greater than or equal to the larger critical point. Example, if critical point are -3 and 2, then x will be less than or equal to -3 and x will be greater than or equal to 2. And here in this case, arrow is coming towards the function. This is function, arrow is coming towards the function, so x will be in between the critical points. Here one critical point, smaller one on the left and larger one on the right. This is how you solve. Let us do some more examples. Let us do this example. X minus 4 mod of x minus 4 less than or equal to 2. What is the critical point? Four, right? So on the number line, the critical point is 4. Mod of less than or equal to 2, right? So it will be 4 plus 2, it will be 6. 4 minus 2, it will be 2. Answer will be somewhere in between this, including 6 and 2. X belongs to 2 to 6. And if question mod of x minus 4 greater than or equal to 2, in this case critical point here is 4. Minus 4 plus 2, 6. 4 minus 2 is 2. We have done this method in earlier class, in lecture number 3, right? We have done this in lecture number 3. Here critical point is 4. So x will be this value of x value can take 2 away from 4 or 2 away towards the left. Right, 2 away to x is the critical point. 2 away from 4 towards the right is 6. 2 away from 4 towards the left is 2. Right. So x will cover all this portion. That is sorry. This is for less than. For greater than x minus 4 greater than or equal to 0. Greater than, right here. Greater than means beyond. Greater than means beyond. Beyond means here 4. 4 plus 2 means 6. 4 minus 2 means here 2. So beyond, right? So it will be beyond this and beyond 6. If it was less than symbol, less than this means in between these two. For less than means x lies within, and for beyond, for greater than, that means arrow away, it will be beyond. Got it? Here it is greater than, that means arrow is away, so it will be beyond this. It will be beyond this. And here its arrow is coming towards, so it will be between these two, between these two. X will be 2 less than or equal to x less than or equal to 6. That is x belongs to 2 to 6, including 2 and 6. Here greater than symbol, right? Arrow is there. So x minus 4 greater than or equal to 2. Here first we have to find the critical point. For this one, its critical point is 4. But here again on the right side it is 2, right? So 2 from 4, that is 6. Again 2 from 4 towards the left, that is 2. So it is going away, so it will be beyond this. Final solution will be beyond this. This between the portion between 2 and 6 will not be included. This will be included. This will be included. That is x belongs to minus infinity to 2, including union 6 to infinity. Got it? We will do some more examples. Here x minus 7 greater than 5. Here what is the critical point? Here is minus 7. So here minus 7. What is there on the right? It's greater than, right? Arrow is away, beyond. Minus 7 count 5 from minus 7. That is, if you count 5 from minus 7 towards the right, it will be minus 2. And count 5 towards the left, minus 7 minus 5, what it will be? Minus 12. Minus 7 plus 5 will be minus 2. Minus 7 minus 5 will be towards the left means minus. How we got this? Minus 7 plus 5 equal to minus 2. And how we got this? Minus 7 minus 5 equal to minus 12. We have done this in lecture number 3. If you forget this, go and check in lecture number 3 again. We have done this type of question in lecture number 3. So since the arrow is going away, that means beyond. The answer will be beyond minus 12 and minus 2. Answer will be, hollow circle this, beyond and this. X is less than minus 12 and union x is greater than minus 2. That is, x belongs to minus infinity to 12 union minus 2 to infinity. This is the answer. What about this? Can you try this? Here here I was okay. Here, what is the difference here? Here arrow is towards the function. Arrow is towards the function means x will be within the critical points. First try to find the critical points. Here for this function, minus 7 is the critical point. And here 10, right? 10 towards the right and 10 towards the left. If you minus 7 plus 10 means it will be 3. Minus 7 minus 10 minus 17. Okay, so since the arrow is towards, x will be within this one, including minus 17 to 3. That is minus 17 less than or equal to x less than or equal to 3. This is the solution. This can be written as x belongs to minus 17 close to 3, close interval. This is the solution. Got it? How you got this 3 and minus 17 means towards the right. This is minus 7. Put somewhere minus 7 on the right. If on the right means you do plus 10. On the left means do minus 10. Minus 7 minus 10 minus 17. Minus 7 plus 10 3, like this. But actual concept how we got this means, what definition of modulus means minus x when x is less than 0, right? And x, the number x itself when x is greater than or equal to 0, right? You are using these two concepts. X plus 7 equal to 10. This is the final value, right? Final value positive. And again, x plus 7, this one, these two. Out of these two, right? First one I'm using the positive when x is greater than 0. Second one I'm using when x is greater than x is less than 0 means minus of x, right? So minus of x. X plus 7 is the x here. X plus 7 is one thing inside the modulus. Minus of the thing inside the modulus. And the thing inside the modulus itself when x is greater than 0 equal to 10. From here you will get minus 10 minus 7 17. X equal to minus 17. That is how we got this minus 17. And from here you will get 3. X equal to 3. This is how we got this number 3. Got it? Next, can you solve this? Here, what is the symbol here? In between, right? What is the critical point here? 0. So, critical point is 0. And here 6. Here on the left 2. Right. F is between 2 and 6. Function is between, the value of the function is between these two. Okay. Now plot on the, this is the usual method. Okay. Plot on the number line. How you are going to do is from this you will get one solution, and from this you will get another solution. Okay, so considering these two, what is the critical point for this? It's 0. 0 plus 2 means 0 plus 2 means 2 here. 2. and 0 minus 2 means minus 2. And for this one, 0 plus 6 means 6, and 0 minus 6, here it is minus 2. From here again, 0 plus 6, 0 plus 6 means this one, 0 plus 6 minus 6, somewhere here. This is how you will get, and it is less than, right? And arrow is coming towards, so arrow is coming towards less than means x will lie within, x lies within. X lies within this and 2, positive 2 to positive 6. X is here and x is here. Got it? System got stuck. Wait, let me check. I have to restart my system. Okay, now we are back. Yeah, we were doing this, right? This question. What does this mean? This is of the format a less than x less than b format. That means x is within a and b, right? So we will solve this within, in between. X is in between type or within. So let us solve. Take down the plot. Here, according to this, critical point is 0. So towards the right, we have to go 2 and 6. First, we will take 2 towards the right. If you add 2, it will be 2. And again 6 more. 0 to 6, suppose here 6. And again 0, say 2 towards the left means minus 2. And 6 towards the left means minus 6. And as the x should be in between. X will be in between, so it will be between these two. First answer is, for the right side it is 2 to 6, and for the left side minus 6 to minus 2. So therefore x equal to minus 6 to minus 2 union, sorry, it will be open 2 to 6. This is the solution. You got this? Shall I explain again? Okay. Let me explain this again. Given that 2 is less than mod x less than 6. Here it is of the format a less than x less than b less than b. That is, x is in between points. Okay. First, what are the points? Let's find out. Here, according to this, x minus 0, right? So 0. X is nothing but x minus 0, right? So 0. So towards the right, we have to go 2 and 6. First, take 2. 0 plus 2 means 2, and again 0 plus 2 means 6. We got 2 points for the right. So x must be in between, right? So between these 2 and 6 for the right side. And for the left side, x minus 2 means minus 2. X, here 0 minus 6 minus 6. So for the left side, the value of x will be between minus 6 and minus 2. Got it? And if it was 2 greater than x greater than minus 6, answer would be different again. For that also we will do in coming examples. Now we got this, right? Therefore x is belonging to this and this, within these two. Minus 6, that is, we can write like this. For this one we can write like this: minus 6 less than x less than minus 2, or this one, 2 less than x less than 6. This format, right? So into union means this 2. For this one it is minus 6 to minus 2 union 2 to 6. Therefore x belongs to this. Got it? Now let us solve this one. Your critical point is 2. 2 is here. So on the right side we have to go 2 first. 2 plus 2 means this 2, add 2. 2 plus 2, 4. And again 4 right here. 2 plus 4, 6. 2 plus 4, 6. 2 plus 2, 4. This 4 and this 6. And now on the left side again, 2 minus 2, 0. 2 minus 2, 2 minus 2, this. And again 2 minus 4, 2 minus 4, minus 2. So answer will be 4 to 6, including 4 and 6, dark circle here. And again minus 2 to 0, including minus 2 and 0. Here minus 2 less than equal to x less than equal to 0. Union 4 less than equal to x less than equal to 6. This is nothing but x belongs to minus 2 to 0, close interval, union 4 to 6. This is the answer, or this format, or this format. Any confusion? Next. here a less than x less than b of it, so x will be in between. Let's find out the point where x lies. Here according to this 3, right? 3 is the critical point here, 3. So on the right side we have to go 5 and 7 from 3. If you go 3 towards the right, 5, 3 plus 5, 3 plus 5, it is 8. Again 3, again 7 times we have to go. 3 plus 7, 10. So x must be in between. So x lies between 7 and 10. This side, on the 8 and 10, sorry, 8 and 10. And on the left, so 3 minus 5 means minus 2. And 3 minus 7 means minus 4. And again on the left side, x lies between minus 4 and minus 2, including minus 2 and minus 4. So according to this, minus 4 less than or equal to x less than or equal to minus 2. Union this one. 8 less than or equal to x less than or equal to 10. This implies x belongs to minus 4 to minus 2 union 8 to 10. This is the solution. If you are watching this lecture directly, skipping lecture number 3, you will not understand this portion. So first watch lecture number 3, then lecture number 4. Okay. Now, next. Here, what is this type? This is inequality question. This is inequality question. Inequality question. What is this type? This is 1 by root over f of x. What I said, 3 types of domain question. First is this one. Number 2 is root over f of x. Type number 3 is root over 1 by root over f of x, right? So this is third one. Here f of x must be strictly greater than 0. F of x must be greater than 0. Here f of x can be non-negative. Here f of x cannot be 0. So third one we will use here, 1 by root over f of x. So this implies 2 by x minus 4 mod of 2 by x minus 4 minus 1 is greater than 0. This implies 2 is a positive quantity, we know, right? 2 is a positive quantity, so we can remove mod from the numerator. But from the below denominator, we don't know what is the sign. What is the sign, so we cannot remove mod. X minus 4, keep mod as it is. And here this 1, we can transfer this side. Yes, so it will be less than 1. 2 by mod of x minus 4 is greater than 1. This means the whole thing should be greater than 1. Yes, the whole thing is greater than 1. That means the whole thing is a positive quantity, right? And here 2 is a positive quantity. 2 is a positive quantity divided by x minus 4, this whole mod. Also, we can directly do, instead of going like this, we can check here mod of x final output will be positive value. Mod is always non-negative, right? So it will be non-negative. So I can cross multiply like this directly. 2 is greater than, cross multiply, no change in sign. This is a positive quantity. So x minus 4 mod of, this can be written as mod of x minus 4 is less than 2. 2 is greater than this, right? So we can write reverse, x minus 4 is less than 2. So what does this mean? Critical point 4. We can use the plot. Point 4. We have to go plus 2 from 4 and minus 2 from 4. So here 6. And here 4 minus 2 means 2. 4 minus 2 means 2. And the answer will lie between 2 and 6. How you get this? 4 plus 2. Here 4 minus 2. See, the concept here is if mod of x is equal to, if mod of x is less than a, this implies minus a is less than x less than a. This one, you remember this one. This is the concept that we are using this. In lecture number 3, we have explained this. So the answer is x belongs to 2 to 6 minus 2 to 6, but x, this 4 cannot be included. Why? Because if we, when x equal to 4, denominator becomes equal to 0, and anything divided by 0 is undefined, so x should be excluded, right? Note in domain y equal to sine inverse f of x and y equal to cos inverse f of x. In both the case, f of x would be this. F of x belongs to range close interval -1 to 1 always. If f of x close interval 1 to 1, this is nothing but -1 is less than equal to f of x less than or equal to 1. This is, so using this we will solve this. Y equal to sine inverse x plus 3, find domain. This implies what I told here. Sine or cos always lies between -1 and 1. Sine also -1 to 1. So here -1 less than equal to x plus 3 less than equal to 1. Here the sine inverse, right? Sine inverse. That's why this one. Then you can solve this by yourself. Try to reduce this to x. To reduce this to x, you have to eliminate 3, right? So 8 minus 3. 8 minus 3 to all. Then here -3, it will be -4, right? Less than or equal to x less than or equal to -2. When you add -3 to all, -4 less than or equal to x less than or equal to 2. Then what is this format? A less than or equal to x less than or equal to b. The same format that we have used in earlier examples. Here. In here we have used same format, right? So we can solve using this method. This implies x is between -4 to -2. Here it's direct question, direct answer. There's only x is there, right? So directly we get the answer. This is the domain. Now solve this. Here the question is y equal to sine inverse of 4x minus 1. Find domain. Let us try to solve this. Here we can write like this: -1 is less than or equal to 4x minus 1 less than or equal to 1, right? So to reduce this to x, first remove 1 then 4. To remove 1 we will add. If you add 1 to all, we get 0 less than or equal to 4x less than or equal to 2, and again divide, multiply by 1 by 4, we get 0 less than or equal to x less than or equal to 1 by 2. Therefore x is from 0 to half. This is the answer, right? And in this case also -1 less than or equal to 1 minus mod of x divided by 2. It is 1. 1 minus mod of x all divided by 2 less than or equal to 1. To remove this 2, multiply with 2. When you multiply with 2, this becomes -2 less than or equal to 1 minus mod of x less than or equal to 2. Now we have to remove this 1. This is +1, so 8 minus 1. 8 minus 1 to all. If you add -1 means -1, it will become -3 less than or equal to minus of mod x less than or equal to -1, right? So it will be 1. Got it? Now here it is minus. I want it to be positive. So multiply with -1. Multiply with -1 to all. So if you multiply with -1, it will become 3. When we multiply with -1 with minus or negative value, we change the sign. 3 greater than or equal to mod x greater than or equal to -1. Got it? So inequality sign reversed. See from here, let's check this one. I will use a different color. Here this is a negative value. Mod x, the final output is always positive. So positive is greater than negative. Positive is positive or 0, not negative. Positive or non-negative. Positive or 0. Always 0 or positive greater than negative. This is always true. So we can ignore this. So directly we can write 3 is greater than or equal to mod x, or mod x is less than or equal to 3. right? So we can plot this mod x, right? So critical point is here 0. So 3 towards the right means 3. 3 towards the left means minus 3. And the solution will be between this, including minus 3 and 3. Therefore, I will use green pen. Therefore, x belongs to minus 3 to 3. This is the answer. This part we have ignored. So the remaining is this portion. 3 greater than mod x. 3 greater than mod x. 3 greater than or equal to mod x can be written as mod x less than or equal to 3. Mod of less than or equal to 3 means directly, even if we don't draw the graph, we can say like this. Minus 3 less than or equal to x less than or equal to 3. Because not. We have done this. Mod of less than a is nothing but minus a less than equal to x less than equal to a. This is the universal. This formula, you can remember this. So using this, we can directly do, or you can plot on the number system. Next, f of x equal to cos inverse 1 minus 2 into mod x whole divided by 3. Find domain. Here minus 1 less than equal to 1 minus 2 mod x whole divided by 3 less than or equal to 1. If you multiply with 3, we get minus 3 less than or equal to 1 minus 2 mod of x less than or equal to 3. When you multiply by 3, then 8 minus 1. 8 minus 1 to remove this 1. If you add minus 1, it will become minus 4 less than or equal to minus 2 mod x less than or equal to 2. 3 minus 1 means 2. Now, we have to remove this minus 2, right? This minus 2. So multiply by minus half. Then it will be, this will be 2. When you multiply something with this inequality with negative value, in inequality sign changed. So it will be mod x 2 greater than or equal to mod x greater than or equal to minus 1. This is negative value. And this is positive value. This is always a universal truth. This is universal truth. Mod x is greater than or equal, this greater than negative value. Mod x is greater than negative value. This one, negative, is always true. So we can ignore this. This is true, so we can ignore this. So this implies 2 is greater than or equal to mod x. Right? This implies mod x is less than or equal to 2. This implies minus 2 is less than or equal to x less than or equal to 2. Therefore, x belongs to minus 2 to 2. Got it? We are using this. Mod of x less than or equal to a minus a less than or equal to a, x less than or equal to a. Or x less than a means minus a less than x less than a. This formula. Next, one advanced level question. Let's do this advanced level question. Okay, here minus 1 less than equal to 1 plus x squared by 2x less than or equal to 1. Okay, just now we have done this. Mod x less than or equal to a, this means minus a less than or equal to x less than or equal to a, right? This whole thing implies this. Then in the reverse way, if we are given this one, we can say this, right? Minus, if minus a is less than or equal to x less than or equal to a, then we can write this one, left side, right? Left side is given, then we can write this one. So we are going to use in this. We are going to use this reverse one, this one in this case. Minus 1 is less than or equal to this, less than or equal to this. This means we can write mod of 1 plus x squared divided by 2x whole thing is less than or equal to 1. Right? This concept, using this concept. Okay, see, now let us observe the numerator and denominator here. Numerator here, 1 is always greater than 0, right? That means 1 is nothing but positive. X square, anything square, anything square is always output is positive, so this is also positive, so the numerator is positive, right? So we can remove mod from the numerator. 1 plus x square divided by mod of 2x. Mod from numerator we can remove the mod. Greater than or equal to, less than or equal to 1. This is, now let us check this whole thing. Mod of anything is always positive. Mod of anything is always positive, so we can cross multiply. Cross multiply, then 1 plus x square less than or equal to 2x. Mod of 2x. In the mod, we have seen this. Mod of constant, here constant and some f of x. This is equal to, constant can be taken out, side the mod. K into f of x. This one we are going to use here. So 1 plus x square less than or equal to 2 into mod of x. Now try to remove this 2. Okay. So here we can transfer this towards this. We can rearrange this one. X square, this one come this side, means 2 of mod x. Okay, 2 of mod x. X square minus 2 of mod x, here plus 1 less than or equal to 0. From here, what is this one? A square minus 2ab plus b square. We can write in that format by minus 2 into mod x into 1 plus 1 square less than or equal to this formula, right? We can convert this into, we can manipulate to this formula, right? Here x means we can write like this, right? Since mod of x whole square equal to x square, that is why. So this is of the form mod x minus 1 whole square. Mod x minus 1 whole square less than or equal to 0. But now observe this one. What we got? Mod of x minus 1 whole square is less than or equal to 0. Anything whole square cannot be less than 0. This is wrong. This is not possible. Less than 0 is not possible. So only possible thing is equal to. Here this less than 0 is not possible. So if you square any number, it will not be a negative number. So this less than 0 is not possible. So we will take this as mod of x minus 1 equal to 0. Got it? This implies mod of x equal to 1. And we know that mod of x equal to a means x can be either a equal to a when x is equal to a, and minus of, wait, see here, mod of x equal to 1. This means mod of when x equal to 1 and minus of minus 1 when x equal to minus 1. So x can be either 1 or x can be either minus 1. Even if x is minus 1, the result will be minus of minus 1, 1. Right? If x is equal to 1, the answer will be 1. If x is equal to 1, mod, if your mod 1 is 1 and mod of minus 1 also 1, right? So x will be either 1 or minus 1. Therefore x will be plus minus 1. Therefore x belongs to set discrete set minus 1 comma 1. This is the solution. This is very important question. First use this concept, then come to this result, come to this conclusion, then solve it, then try to manipulate into a mathematical formula a minus b whole square or x minus 1 whole square, this one, mod x minus 1 whole square. Then use this concept, any number to the square is not negative. So this is less than or equal to 0. This less than 1 is not possible. So we are using the equal to. So using equal to, we are solving this. and we get answer as x belongs to discrete set minus 1 comma 1. Got it? This is important question. If you don't understand, rewind and watch it again. This is important question. Can you try doing this, solving this? Find the domain of this 1, 2, 3, 4, 5, 6, 7, 8 questions. Okay, let's solve them one by one. First one is find the domain of y equal to 1 by. This is 1 by root over f of x. 1 by root over f of x. F of x should be greater than 0. It is 1 minus mod x should be greater than 0. This implies, I will solve it fast. We have done this in previous examples. Bringing this to the left, to the right. When you transfer this, it will become minus 1. Okay. So mod x is less than 1. Multiplying by minus this minus, I'm transferring it here. So it becomes 1. So it is mod x to, therefore 0 to 1 and minus 1. This is the solution. Therefore x belongs to minus 1 to 1 opened. That is minus 1 less than, not equal to, less than x less than 1. This is the solution. For number 2, this is 1 by f of x format. This is 1 by f of x format. So f of x cannot be equal to 0. So 1 minus mod x does not equal to 0. This implies mod x does not equal to 1. Therefore, x belongs to R, any real value of x except minus 1 and 1. Why this one? You know the reason? Because x is equal to 1. This means x can be 1 or minus 1. Mod of 1 equal to 1 and mod of minus 1 also 1. That is mod of minus 1 equal to 1. Therefore, x can take either 1 or minus 1. So, when mod x is equal to 1, mod x should not be 1. That means you cannot put the value of x as 1 or minus 1. From this, we get that mod of x should not be 1. Any other number is okay. Any other real number is okay, but not 1. So, if you don't want to get mod x equal to 1, then you should not take the value of x as 1 or minus 1. Got it? So, this is the final answer. Number 3, y equal to root over, this is f of x format. F of x should be greater than or equal to 0. That is non-negative. This should be, inside things should be non-negative. 2 minus 2x plus x square should be greater than or equal to 0. Okay, we can rewrite this x square minus 2x. This 2 can be written as 1 plus 1, right? Greater than or equal to 0. From here, you will get this formula. X minus 1 whole square plus 1 greater than or equal to 0. This is always positive. Anything square is always positive. And this is also positive. 1 is positive. Square of any number is positive. So, for all, this is true for all x in R. Therefore, x belongs to R. This is the answer. This is the answer. Positive plus positive greater than 0 is true in all cases. Or if both are positive, if both are 0, then equal to 0, true. So for all R x, the given function is true for all R. Next, number 4, y equal to root over minus of mod of x minus 3 plus 2. Here, this is f of x format. Root over f of x format. So f of x should be greater than or equal to 0. F of x must be greater than or equal to 0. This means minus of mod of x minus 3 plus 2 should be greater than or equal to 0. This implies x minus 3 is less than or equal to 0. Go. Take this to this side minus 2, then again multiply with minus, so sign changed. And minus 2 become plus 2. And this one. Now, 3 here. Go towards the right. 2 points from 3 towards the right, that means 5. And 2 points towards the left from 3. That means 3 minus 2 means 1. So, x should lie between this 1 and 5, including 3. Therefore, x 1 less than or equal to x less than or equal to 5. Therefore, x belongs to 1 to 5. And then number 5. Here y equal to sine inverse x squared by 2. For sine or cos, we know that minus 1 is always less than x squared by 2 less than or equal to 1. Right? And here, try to remove this. Try to remove this 2. So multiply with 2. Multiply with 2 in alt. So minus 2 less than or equal to x square less than or equal to 2. Okay. So now this is a negative value. Anything square is a positive value. Negative less than positive is always true. Always true. So this can be ignored. This can be ignored. So now the remaining statement is x square is less than or equal to 2. This implies x square less than or equal to 2. Now take root. Take root. Taking root over x square less than or equal to root 2. I told you root over x square is nothing but mod of x. So here it will be mod x less than or equal to 2. Right. So it will be critical point from here is 0. 0. From 0 go root 2 points and minus root 2 towards the left. So answer will be minus root 2 to plus root 2. This implies minus root 2 is less than equal to x less than equal to root 2. Therefore x belongs to minus root 2 to root 2. Got it? Or you can use the concept root over less than 1. This implies minus 1 less than equal to x less than equal to 1. If I use that method, let me create some space. Let us use this format. We can solve this in different way, or we can solve like this. See, mod of x less than or equal to 1. This implies minus 1 less than or equal to x less than or equal to 1, right? This also can imply back, right? Reverse is also true. If this implies this, then this implies this. Both are true. So we will use this reverse one. So here, now this will give this mod of x square by 2 is less than or equal to 1, right? Here, see, this is positive, and inside this mod is positive. Why? Anything whole square is always a positive value. So x square by 2 is positive, so we can remove x square. Here also we can remove mod here because x square itself is positive within. So x square less than or equal to 2, cross multiply, right? This is take root x square less than or equal to root 2, x less than or equal to root 2. Root over x square is nothing but mod x, and then we know that mod x less than or equal to a means minus a less than or equal to x less than or equal to a. Therefore here minus root 2 less than or equal to x less than or equal to root 2. Therefore x is minus root 2 to root 2, minus of root 2 to root 2. Got it? Next, only some 3 questions. Here y minus 1 less than or equal to 4x minus 1 less than or equal to 1. We have to reduce this to x, only x. We have to remove minus 1 and 4. So first, to remove this, we can add plus 1, right? Add plus 1. Add plus 1 means here it becomes 0 less than equal to 4x less than equal to 2. Then divide by 4 to remove this 4. 0 divided by 4 is 0. Here x less than equal to 1 by 2. 2 divided by 4 is 1 by 2. Therefore, this implies x is lying between this, right? X belongs to 0 to half, including 0 and half. Right? This is the answer. And for this one, number 7, this is inequality question here. F of, given that f of x is greater than 0, that means positive interval. We have to find positive intervals. Let's draw a number line. Let us draw a number line here. From here, root is 1. From here, root is 2 by 3. From here, root is 7. From here, it's minus 8 by 7. From here, minus 3. From here, 2. From here, minus 6. So, place them increasing order from left to right. So, minus 6 is the smallest. Then, minus 3. Then, minus 8 by 7. Then, 2 by 3. Then, 1. This one. Then, 2. This is 1. This is 2. Then after that 7, yes, 7 is the largest one. So the rightmost is here, positive. 7, check 7, where it comes from. 7 comes from even bracket. Power is here even, so it will not change. Sign will not change. Again 2, check 2. From where it comes, check 2 is here, right? 2 comes from even power, so it will be positive again. 1 comes from even again, here it will not change. Next 2 by 3. 2 by 3 here. 57 is odd, so this will change to minus. Now minus 8 by 7. Minus 8 by 7 power is 927. This is odd, so it will be changed to plus again. So minus 3. Minus 3 comes from this bracket. 17 is the power. 17 is odd, so power minus this sign will be changed to negative again. Minus 6 comes from even 12, right? So it will remain as not changed. Sign will same. Now it is given that the function f of x is greater than 0. So we have to find the positive interval. Positive interval here, let me use different color, pink, red. Positive means from here to this one, and again from 3 to 8 by 7. These are the positive answer. This implies x belongs to minus 3 to minus 8 open intervals. Minus 3 to minus 8 by 7 open interval, and then union 2 by 3 to infinity all. But check the denominator. Denominator cannot be minus 3. Minus 3 is included or not, just check here. Minus 3 not included, so this is okay. For this we have checked minus 3 not included, correct. Then denominator 2 is included here or not. 2 not included. 2 is here included, so 2 should be included here, not down somewhere here before. For time being, not down here. 2 should be excluded. Then 6, minus 6 should be excluded. And numerator, let's check in the numerator. If I put here 1, here 1 is there, right? So if I put 1 in the numerator will become 0. Everything will become 0. 0 greater than 0. Here it is f of x is greater than 0. So 0 greater than 0 is false. 0 greater than 0 is false. So 1 also should be excluded. 1 cannot be in this. 1 should be excluded. 2. If I put 2 is already excluded here. 6, minus 6 already. So from this we will exclude this discrete set 1, 2. Let's write the negative first. Minus 6, set of minus 6, 1 and 2. Discrete set of this should be excluded. This is the answer. No, something is wrong. Wait, let me check. No, here 6 is not included. Minus 6, no need here. Minus 6 is nowhere in the, wait a second. Here say minus 3 to minus 8 by 7. Minus 3 to minus 8 by 7. Minus 6 is already not included. So we don't need to bother about this. We don't need to bother. Only 2 is here. Only 2. We have to think about 2 and 1. And then what about minus 2 by 3? 2 by 3 is not included here also. 2 by 3 not included for this bracket. This is okay. Then 7 is included here. So 7 should be excluded. If we put here 7, it will become 0. 0 greater than 0 false. So 7 should be excluded. So 2 and 1, 2 and 7. 1, 2 and 7 should be excluded. Discrete set 1, 2, 7 excluded. What about minus 6? Minus 6 not included at all here. See, minus 6 is here. Not included. Not included. Minus 2 excluded. 3, minus 3 not included at all here. Minus 3 is not included here. This is open, so minus 3 is not included. Or the numerator minus 1. Minus 1 is included here. 1 is included here. So we have to exclude here, excluding here. 2. 2. If we keep 2, the whole thing is undefined. So we are excluding 2 here again. 7. If we put 7, becomes 0. 0 greater than 0 is false. So we are excluding 7. 8 by 7. 8 by 7 is not included here at all. 2 by 3, right? 8 by 7 is less than something here. Minus 8 by 7 is not included. See, minus 8 by 7 is not included. So this bracket is also defined. Therefore, final answer. Therefore, final answer is x belongs to minus 3 minus 8 by 7. Open. Union open 2 by 3, comma, infinity minus this discrete set 1, 2, and 7. Or we can write this as x belongs to minus 3 to minus 8 by 7 union 2 by 3, comma 1 union 1 to 2 union 2 to 7 union 7 to infinity. Like this or like this. But this is a better format, better way to represent. But if it is a multiple select question, they may give this as well in the answer. So we have to choose both. So how you represent the answer, you should know all the format of the answer. Next, I think this will be the last one. Yes. Here, given function is of the format f of x root over f of x, then f of x should be greater than or equal to 0. We are going to use that. Now, this implies 1 minus mod of x divided by 2 minus mod of x is greater than or equal to 0. This implies you can minus common. You can take minus common, minus 1, right? From the denominator also, you can take minus 1. Minus common, so minus minus cancel. There's no multiplication involved. Here, numerator minus and denominator minus, they cancel it out. So no sense in sign, as there is no multiplication involved, only cancellation is involved in the one side only. If we cancel from this side, oh, that also remains the same. Cancellation only, right? Multiplication or division is not involved with sign. So no change in the sign. Here, from numerator we get 1, and from denominator we get 2. 1 and 2, plus, minus, plus. We get the rightmost plus, minus, plus. As the degree are odd here, 1, 1, odd degree. So it is greater than equal to 0. So positive interval should be taken. So 2 to here 2 to infinity, and here it will be dark circle 1 to negative infinity. Here why? Can anyone tell me why I use here hollow circle? Hollow or not dark circle? Because in the denominator, when x equal to 2, denominator equal to 0. If denominator equal to 0, then undefined. So we are excluding 2. Excluding 2 from the answer. This implies mod x is less than equal to 1 or mod x is greater than 2. Here we are excluding that equal to sign here because of this hollow circle, right? 2 is greater than 2, x mod x is greater than 2, or mod x is less than or equal to 1. Okay, this implies minus 1 less than or equal to x less than or equal to 1 union here mod x is greater than 2, right? Or means union. We will represent or with union. Here mod x greater than 2 means minus infinity to minus 2. Wait, I will show it. I will not jump. I will show how it comes. Here mod x greater than 2. Then try to draw. Critical point 0. So towards the right 2 point. Towards the left 2 point. Means 0 plus 2 means towards the right plus 2. 0 minus 2 minus 2. So it's greater than right. Means function is here and arrow is going away. So the answer would be this and this. Therefore the answer is minus infinity to minus 2. Union 2 to infinity. Got it? Here the answer will be this side and this side, and here no equal to sign, so we are using open bracket. Therefore, now let us adjust this answer here. All both union is right, union minus 1 1 for this, and for this minus 2 and 2, minus 2 and 2. So the answer is from here minus 1 including minus 1 to 1. This is the answer. And from the second one, from here minus 2 to this and 2 to this, right? Therefore x belongs to minus infinity to minus 2 open, union minus 1 to 1 closed, union 2 to infinity open. This is the answer. Minus 2 minus 2 minus infinity to 2 minus 2 open, union closed minus 1 to 1 closed, union open 2 to infinity. This is the answer. Let's end today's class here. Thank you.